So in this question, we're being faced with an inclined plane and there's an object going downwards on the plane. So in part 8, we're being asked to find v at the bottom of the inclined plane. So the velocity once the object reaches the end of the plane. So to even begin doing this, we have to get vx final minus the vx initial, and then we can equal it to 2 times the acceleration times the displacement that the object faces. And this can be simplified since we're only trying to look for v2, aka v final when it reaches the bottom of the plane. We can substitute the acceleration with g sine of 0, which is the parallel to the plane, and then times the displacement. And then we can just start plugging in values. So we know that 2, we know that g is 10, and we know that theta is 30, so sine of 30, and we know that the displacement is 3 meters. So we can also just start simplifying this and try to find the square root of the problem. So we have 2 times 10, sine of 30 is half, and then times 3. And when we simplify this, we get the square root of 30, which means that the velocity, at the bottom of the inclined plane should be 5.477 meters per second. And perfect. And now to move on, let's do part B. So for part B, it's telling us that if we already know that mg is 0.3 of this object, what will be the velocity when it arrives to the bottom of the inclined plane? So now we're being given the mass of the object, unlike in the first problem. So for this one, we'd have to do the sum of forces in the x direction, which is equals to max. And then we have, once again, mg sine of theta minus the force of friction equals ma. And we don't have to worry much about friction in this case, but we might use this equation. And now the sum of forces in the y direction, that's going to be may equals 0, because we know that the object is not moving up or down in the y direction. And then to find that, we would have mg cosine of theta minus n, the force. And then once again, n minus mg cosine of theta equals 0. So in all of these cases, we know that it's equaling 0 because there's no movement happening in that direction. And we finally end up with the force is mg cosine of theta. So now let's actually use this equation in solving for the velocity at the bottom of the inclined plane. So we would first start with, as we solved for, mg cosine of theta is equal to the force ma. And in this case, we would try to take out m completely. We would just divide by m on both sides, and then we can just, get rid of it for now. And then to solve for the acceleration, we'll have a equals g cosine of theta. And then since we're trying to find the parallel, we have ax prime equals g sine of theta minus g cosine of theta. And then ax prime will be, as we can start plugging in, 10 sine of 30 minus 0.3 times 10 times cosine of 30, of course, And so ax prime will leave us with 10 times half minus 0.3 times 10 times cosine of 30. And then, since we know v2 equals 2a times x, v2 would equal, in this case, 2a times 3, the displacement. So this would be a prime, and then when simplified, that would probably give you a much larger number, which let me plug it in now. And yes, so a prime would actually leave you with 2.5 for 0. And this would be what you get when the object is at the bottom of the inclined plane.